Why do we care? Well, ecosystems provide us provisioning services. Our food, fresh water, wood, fuel. These all have a place in the marketplace. We actually put value on these. But also there's regulating services, climate, floods, disease, water, pollination. They rarely have value in the marketplace. They have value, but not in the marketplace. There's the cultural services, aesthetic, spiritual, recreational, religious. Also, other than tourism, probably don't have much value in the marketplace. And then there's the underlying supporting systems, nutrient cycling, soil formation, etc. And they all link, and this was particularly put together for developing countries and poverty alleviation, constituents of well-being, security, basic material for good life, human health, good social relationships, and the Amartya Sen's freedoms of choice and action. So fundamentally, biodiversity has got innate value. It's got a huge amount of market value, but it's got a huge amount of off-market value. In the last half century, we've tried to optimize and maximize the provisioning services, and in fact, most of these have gone up, but they've come at the expense of the regulating, supporting services. So if you think about climate change, biodiversity and climate change are inextricably interlinked, and yet we've got two conventions that rarely talk to each other, basically. Biodiversity is impacted by climate change, but biodiversity can also help people adapt to climate change and mitigate climate change, and that's the part that's been missing. Climate change directly affects ecosystems and biodiversity through changes in temperature, precipitation, and for marine systems, sea level rise, but also indirectly pest outbreaks, wildfires, etc. So again, one has to think, how does climate change affect biodiversity? The species that are most at risk are ones with low population numbers, very restricted or patchy habitats, could have been because of fragmentation of ecosystems, or they've got very limited climatic ranges, i.e. those who are on the top of mountains, those who are in polar regions. Therefore, the ecosystems that are very sensitive are coral reefs, mangroves, high altitude and high latitude systems. But again, must think of climate change in the context of all other drivers. And of course, for the oceans in particular, we now also have to think about ocean acidification. As atmospheric carbon dioxide goes up in concentration, it's also changing the acidity of the oceans, potentially adversely affecting coral reefs, potentially adversely affecting any shellfish, so crabs, lobsters, etc. So we have to say that these issues are inextricably linked, and the linkages need to be understood. This is the frightening statistic. Could be wrong by a factor of 5 and it would still be frightening. For every 1 degree rise in global mean surface temperature, for up to a 5 degrees Celsius rise, we would predict eventually 10% of all species will be lost. If this were to be correct, it would say a 5 degrees Celsius change, which is quite plausible over the next 1 to 2 centuries, we would lose half of all species on Earth. Hopefully that is completely and utterly wrong, but even if it was wrong by a factor of 5, it would still be very serious. And so therefore, as one thinks about doing an impact statement, one has to say, what happens to biodiversity at the genetic, species, ecosystem level? How does it affect the ecosystem service, provision and regulating, cultural and supporting? And what are the implications of that for human well-being? Recognising some issues have got market value, other issues do not have market value, but have incredible value for human life. And so what we're trying, I'm chairing, or co-chairing I should say, a UK ecosystem assessment. We're looking at the UK in total, we're looking at England, Wales, Scotland, Northern Ireland separately. What we've realised is you have to be very careful not to double count or to miss something when you try and do value. What we humans use are the so-called final ecosystem services, the ability to grow crops, the ability to grow trees. We recognise the importance of wild species diversity, the way it controls local climate, the way it detoxifies our wastes. So we value these. These services are primary and intermediate, and you actually don't value them. It sounds strange, because you've captured the value here. They support these. So we then recognise if you've got food, you get ecological services, but you also have other capital inputs, of course. So what we're trying to do is say, what's the food worth in the United Kingdom? Drinking water, fibre, energy, etc. What comes from the value of the services, and what comes from other capital goods? And so we are valuing our ecosystem services. And then we're going further by saying, but you cannot put everything in economic terms. And therefore, there are things such as mental well-being that are very, very important. And so we're trying to say to our cabinet, we're trying to say to our Treasury officials, there are some things that you can put monetary value on and some things you can't put monetary value on, but you must value both of them. Absolutely crucial to value both. And we're trying to say to our Treasury, gross domestic product is an interesting concept, but it's totally flawed. And that is, it's a value of wealth, but it's a very inaccurate value of wealth. And so we're trying to point out that you should use, as the bank has been talking about for more than a decade now, 4 forms of capital: built capital, natural capital, social capital, and human capital. And this talks to the natural capital part. It doesn't, and it touches upon some of the social capital, but only indirectly. And so human security. What we've got to realise, sea level rise is a crucial issue. And therefore, when one thinks about human security and the impact of climate change, one has to think about how sea level rise, increased storm surges will affect some of the major deltaic areas of the world, and of course low-lying small island states, Tuvalu, the Maldives, etc., Kiribati. Also got to recognise it's an equity issue, which is why it's so hard to negotiate the climate convention. The countries in grey are the ones with the highest per capita emissions of greenhouse gases. The ones in red are the countries which are most vulnerable. And there's a few countries that are shaded like this, where there's reasonably high per capita emissions and reasonably vulnerable. But to a first approximation, the industrialised world has caused the problem, and it's developing countries that are the most vulnerable. This is a very, very tricky issue. Will climate change spread conflict? Will climate change cause migration? And I think it's a really open question at the moment. But you could, at the most simplistic way, say sea level rise will probably, potentially displace tens of million people. Some may stay within their own country, some may cross borders, and of course the implications of the two are quite different. We've already got food shortage and hunger in many places today, especially in sub-Saharan Africa. Climate change will adversely affect it. We've already got water shortages in sub-Saharan Africa. Climate change will exacerbate it. We're depleting natural resources anyway. Climate change will exacerbate it. We've got an incidence of disease in many developing countries. They don't have adequate healthcare facility. Climate change will exacerbate it. And we'll have more increasing severe weather. So the question is, to what degree will climate change, when coupled with other stresses, risk local and regional conflict and either in or out of country migration? And it will be very dependent on the social, economic and political circumstances. So when one's trying to do an impact statement, one's got a very wide, broad portfolio of issues to think about to try and do anything quantitatively on this issue. So how do we mitigate the risks? Well, the first question is, who defines the risk? It's not the scientific community. Defining dangerous anthropogenic perturbation clearly has to be a judgment, and it's a socio-political process, but informed by scientific knowledge. It's clear that in Copenhagen, and I was asked what I thought about the Copenhagen talk, and I said as a scientist it was an unmitigated disaster, but as a full member of the British government it was clearly a step in the right direction, and it was indeed both. The governments of the world said we should try and limit climate change, human-induced climate change, to 2 degrees Celsius, because as you go to higher and higher temperatures, the negative effects of climate change get worse and worse and worse. My personal view is we haven't got a hope in hell of stabilising at 2 degrees Celsius, and therefore we need to start to prepare for 4 degrees Celsius, and that's globally averaged. The land areas on average will be 50% more, the high latitudes a factor 2. Reason is, we're already at 385 parts per million of CO2 equivalent. To have a 50-50 shot of 2 degrees Celsius, you have to stabilise at 4. The US is doing nothing to try and reduce greenhouse gas emissions. China and India got incredible economic growth, incredible demand for energy, incredible use of fossil fuel. I would argue we're on a pathway to 550 or 650, and therefore they've got a 50-50 shot at 3 degrees Celsius at 550, 4 degrees Celsius at 650. So again, doing an impact analysis, I would not focus on 2 degrees Celsius. I would look at the impacts of 2 degrees Celsius, but I'd also look at the impact of a global mean surface temperature of 3 and 4, and look at a probability, which I'll come back. We need to put a price on carbon, we need technology transformation, and we need to mobilise behaviour change. I think for too long we've focused on the first two without thinking about behaviour change. I think we've made a real mistake. If you don't look at behaviour change of individuals, businesses and public sector, you will not realise the potential of technological transformation. And I'm not going to focus on this, I want to look at something else. We therefore need efficient production and use of energy to the degree possible, fuel shift, coal to gas, whole range of renewable energy. We need carbon capture and storage, as you use fossil fuel to produce energy, but then effectively you capture the carbon dioxide before it's released to the atmosphere and you subduct it into a depleted oil well, gas well or a saline aquifer. Nuclear power will be a significant proportion of energy in most countries of the world, not in Germany probably for the time being, but in most countries, in India, China, the USA, England, France, Japan, Korea, etc. Probably around 20–25%, probably not much more. We've also got to manage our forests and our agricultural soils. So there are potential technological options, but you also have to place it in the right policy framework and behavioural framework. Ecosystem-based mitigation, straightforward, linking biodiversity with climate change. We need to protect our natural forests and our peatlands. We need to sustainably manage our forests. We need to reforest, but using native species, not exotic species. We need to manage our wetlands, and we need to restore our degraded wetlands, and we need much more sustainable agricultural practices. Reduce methane emissions from rice production and from livestock, reduce nitrous oxide emissions from use of fertilisers. So we need to link the ecosystems with climate change. This simply shows you from IPCC for a series of sectors: energy, transportation, buildings, industry, agricultural, etc. If you put a price of $20 per tonne of CO2 equivalent, 50 and 100, putting a price on carbon will stimulate change to a low carbon economy. And as you can see, as you go from $20 to $100 in most of these sectors, you get increases. But the other point of this is there is potential to reduce greenhouse gas emissions in every one of the sectors. So we can't focus only on energy supply or energy use in transport, energy use in buildings or industry. It literally means we've got to look at the full set of sectors and the impact of different prices. We clearly need a range of policy instruments, and I won't worry about this, but it literally goes all the way from energy pricing strategies to trading carbon, voluntary programs, education, and of course research and development, both by governments and the private sector, is important.